Chuck. Camille, thank you again for that great start to this workshop. So Chuck is a research biochemist with the U.S. Forest Service Rocky Mountain Research Station. He studies the biogeochemical processes that regulate the delivery of clean water and that sustain productive soils and forests. For the past decade, a lot of Chuck's research has been addressing the watershed effects of severe wildfires, extensive bark beetle outbreaks, and associated forest management activities. So Chuck, I'll let you go ahead and start. Thank you so much.
Great. So thank you, Camille. That was a really nice overview. And so now we're going to dive down into a couple sort of local vignettes. I tried to talk my way out of giving a talk for this, but Maren wouldn't let me off the hook. So you're stuck with me. And I wanted to kind of reach back, especially after Camille sort of threw that down and said that lodgepole pine doesn't have any problems. Of course, and that's kind of the status quo, and this quote that I just found last week in the very first journal that we have at the research station from the Proceedings of the Society of American Foresters, with a keynote by Teddy Roosevelt. We were already saying lodgepole pine has no problems, and you can see from E.R. Hodson, he makes this comment that people are already recognizing that, and then he kind of went on and described a study where he was finding some problems. And I kind of wanted to kind of move on with that. Growing up in Colorado, growing up as a CSU student, I've always thought lodgepole pine's got no problems. We've got other things to worry about. So this workshop sort of reminds me of workshops we had, seems like only yesterday, when we were starting to talk about the bark beetle outbreak, and we were freaking out, and people were talking about the whether there was going to be fire, whether there was not going to be a fire, whether we should manage, whether we should not manage. And we had a lot of sort of knowledge gaps types of workshops like that. And it's really, last summer kind of really came home to me as I saw these maps kind of merging, and we can see that the 2020 fires kind of laid down on top of that, those bark beetle areas. And we know that there were some fires we've been studying up along the Colorado-Wyoming border. Some of them happened to 2016. The Beaver Creek fire really caught people's attention. But last year, we had 600,000 acres across the state, and a lot of that was in these sort of late phase, or what I'll probably call gray phase, lodgepole pine stands. And that means stands that have been dead for quite a long time now, so about 15 years in a lot of cases. So we had an opportunity to start looking at the regeneration piece in some of these early bark beetle stands and other disturbances, kind of as a consequence of some of the bark beetle salvage work we did near the Fraser Experimental Forest. So the Church Park fire happened fairly early on. It was 2010, and it burned in some areas where we had done some salvage studies. So we were able to compare regeneration in uncut areas and cut areas, and then burned and burned and cut. And the piece I'd like to just sort of show you now, looking at across various height types, so these are looking at recruits and then advanced regeneration, is within the first 4 years following the fire, we saw virtually no conifer recruitment at all in these stands. Aspen did okay, fir didn't do well at all, and we saw no pine. You see how it jumps up following the harvest, as we would typically expect. And in this case, it was a very small fire, burned at high severity, and we assumed that a lot of the reason that we didn't get regeneration was because of cone consumption, and the fact that we had basically burned up all the cones, not just opened cones, but consumed them. Looking up on the Colorado-Wyoming border at 4 different fires, the Beaver, Rhine, Silver Creek, and Badger fires burned in 2016 and 2018. This is work that we did with Dan Tinker and folks at Wyoming. We found very poor regeneration in 3 out of these 4 fires. So this is looking at about 1,500 or 15,000 trees per acre following the burn in the Badger Creek fire. But all the rest of these burns had much less than what would be considered a well-stocked stand. And this is looking at new recruits, so less than 10 centimeters, and then looking at advanced regeneration as well. And in this case, we looked at serotiny, and we figured that the cause of this was serotiny. So we see high variability in just this very small sample size of gray phase fires. If we dive in just a little bit more on that same picture, these are the same stands plotted with the regeneration density of the recruits and looking at the percent serotiny. We know that that's a really key piece. So we see that it's not until we get over half of the cones on a tree are serotinous do we actually have any decent regeneration. In other words, we're having very little until we get up to this point. And then this was the Badger Creek fire again. In this case, we see pretty good regeneration. Looking at serotiny across the areas that we've been working in, these are the fires, and this is some serotiny data that we got from FS-Veg. It's very variable. There are a lot of stands that have serotiny, almost as many that don't have it. There's mixed stands, so it's pretty variable. We don't have a really good idea what controls serotiny in a lot of stands. There's some idea based on work in Yellowstone. It has to do with elevation, but we really don't have a good handle on it, but we can definitely see the importance of it. But the other point I wanted to make, and this is something that really jumped out to my colleague Dan Tinker, was when they did their studies in Yellowstone, and that's what this is, the work that Dan did with Monica Turner and Bill Rami, they found that you didn't really need much serotiny in a stand to get well-stocked regeneration. So what they would, even when they had only 10% of the stand that had serotiny, they had 2,000 trees per hectare. If they had 65%, which is what we have here, they were over 200,000. So that's 10 times more than we're showing. Looks different to me. I don't know how much to make of that, but it looks like we've got different patterns here than they had up there. Okay, so the quick story, I've been doing a study, and this is something that we sort of spun up with people like Kevin McLaughlin right after the fire, as we were talking about having these kinds of conversations. What are we interested in? We were really curious about the serotiny question. There had been some work that had been done here right after the beetle outbreak and elsewhere following the beetle outbreak, but there really haven't been a good study looking at how much seed viability there are in these cones. So the trees that are now out there, the cones that were built on those trees, they have a range of ages at the time of tree death, but now we're 15 years later. So some of those cones are now getting to be 45 years old. And so we were interested in how well the germination looked on those. And so I'd just like to share a little bit of this information. I've got a lot more coming. This is preliminary. We've got information from 600 of about 1,000 cones. We'll be finishing this up in the next few weeks, and we'll have more to share. But the take home of this is that on average, we spread across the 4 main fires, 2 different stands per each fire, 10 trees, et cetera, et cetera. We're looking at a lot of different cones, and we're finding on average about 34%. That's going across these different age classes of cones, but we see super high variability. So the Mullen fire has about half the germination rate of, say, the Cameron Peak fire. And in some cases, we're seeing a fairly strong decline with age. In some cases, it's not very clear, but we definitely see overall a decline in germination with time, which is similar to what was seen early on. The difference between those early studies, they were starting out at 70 to 90% germination for the younger cones, and we're starting out at about 40. So if we think about this in terms of the numbers of seeds that are out there and available to regenerate trees, we're getting on average about 3 seeds per cone, which doesn't sound all that much. If you scale that up and you think about how many cones there are per tree, how many trees there are per acre, we might scale that up to a couple million seeds per hectare, but that doesn't necessarily give us the number of trees that we would be needing to restock. And I guess that's one point I'd like to point out. we're seeing regeneration in some of these stands, but so we have presence of trees, but we have very low densities. And so that's something that as forest managers, we're interested in. We want to have well-stocked stands if we're thinking about them for, at least for a timber objective or certain objectives. I know for other objectives, the density is not important, but that's something that foresters tend to think quite about. So just a couple take homes. We see some regeneration. It looks a little bit low relative to other Serotiny studies. So it does seem like things are either lower or declining. We have germination rates, but it's not terribly high levels. They've declined since the onset of the beetle outbreak. And we do have seeds coming out, but the question will be, are they going to regenerate into well-stocked stands? Based on simple back of the envelope calculations, 1.5 to 1.5 million seeds per hectare might only be about half as much as we need to get up to about 1,000 trees per hectare if we think about the predation on seeds, competition, and so on. So just a couple quick take homes. This is based on a lot of historic information from people who've worked at Yellowstone. We should be expecting lots of variability. We're seeing that, and we should embrace that. We're not going to have well-stocked stands everywhere, and it's lodgepole pine. We probably don't want well-stocked stands everywhere. Serotiny is very important, but we don't have great information about where it is, so we have to think a little bit more about that and survey that. It's really important to think about what kind of fire severity and what that means in terms of releasing seeds. So at Yellowstone, for example, the high severity crown fires actually created the lowest density of seedlings, which seems a little counterintuitive, but like our Church Park study, those actually are consuming the seeds. You need to heat up the cones, but not consume them. And then my buddy Dan Tinker would say, if you're interested in this question, you really need to go out and sample a lot of sites. They did this work studying at 700 different plots up in the Yellowstone area. And so you've got to be able to get out there and look at a lot of trees in order to understand what the regeneration situation is going to be. And with that, thank you very much. Lots of people have helped out with this, and I'd love to talk more about it with you. Thank you.
Awesome. Thank you so much, Chuck. Sarah, why don't you go ahead and start loading your talk? And in the meantime, we've got a couple of minutes for questions. I don't see any in the chat, and I don't see anyone's hand raised. So if you do have a question, just go ahead and speak it out.
Thomas has a question, and I would love to hear it.
Thanks, Chuck. Thanks, Baron. So in terms of planting, if we get to the point where we decide or it's suggested that we want to plant lodgepole at a certain point, would there be any reasons for thinking long-term trajectory to plant non-serotinous lodgepole? Or, I mean, is the goal to just plant serotinous lodgepole moving forward with the expectation that you're going to see more fire, and that would set you on a better trajectory for potential future recovery from the next fire 50 years down the road? So I guess that's the sort of first part of the question. And then I wonder, operationally, if you call up the nursery, can you say I want serotinous seedlings, or is it a matter of when collecting lodgepole to send seeds to send to the nursery, should you only be collecting serotinous? Is that focus only on serotinous lodgepole gonna set us up for, are we missing something by focusing on that? So would be interested to hear, Chuck, your thoughts on sort of implications of all this.
Yeah, that's a really, really good question. And that's the problem when you ask a soil scientist a really good forestry question. But luckily, we have people like Wayne Shepard on this call and lots of people that actually probably have a good answer for that. I'm sure folks from the State Forest Service would probably know that right off the top of their head about that. I could make something up, but I really don't know the answer to that. So thanks for that great question, Thomas. And hopefully somebody with that experience can help us out here.
Any thoughts from any
Wayne,
of the...
you're making me feel bad. So
All right.
how about we come back to that one, Thomas, and I will look into that because I think that's a great question. I mean, what little I do know is that in stands that you see in the field, you don't see the serotiny developing in cones until they get to be quite a bit older. Based on the little bit in terms of the mapping of serotiny in stands around Colorado that we've dug into, I'm not so sure how great that data is. So being able to go out and clearly identify serotinous and non-serotinous stands, I think you probably just go out and you could probably find those. The problem right now is most of those trees have been dead for 15 years. So finding good seed stock and developing those is, to me, that seems like kind of a nursery hiccup right there. I don't know. And hopefully Kevin McLaughlin and Kevin Zimlinghouse will talk in a while about what they have at the Bessie nursery or where they get their trees produced, what kind of seed stock they actually have, because it could be quite old actually. So that's another thing to be thinking about.
Thanks, Chuck. I'll throw the question in the chat in case folks want to think about it there.
Thank you, Thomas. Any other questions for Chuck? Chuck, I did see Teresa say this is the first she's ever heard of non-serotinous lodgepole. And I do think that serotiny story is a pretty pervasive one.
Yeah.
And so your study is a really profound look at that.
One of the things that one of the many sort of bad things I learned from Wayne Shepard, and he a lot of the lodgepole ecology I learned from him, and he just said all these stands are mixed. I remember him saying that multiple times. And so I assumed that there was serotiny in every stand I ever walked into. And it wasn't until we started working up on the Colorado-Wyoming border, and Mark Westfall, actually, who's on this call, when he was looking at some of our poor regeneration on the Beaver Creek fire, and we were like, well, come to find out there's no serotiny. Did you know that? And Mark was like, yeah, I knew there was no serotiny here. There's no serotiny anywhere in this part of, going up towards Hog Park. He knew, there are areas that are known to have poor serotiny. So the land managers kind of have a handle on that. When we were out looking for serotiny this fall, Kevin McLaughlin and I drove basically from Highway 14 all the way to Long Draw Reservoir, all along that road, and found no serotiny. And we were just like, we just want to find a couple trees so we can cut them down and we can do this work. And it was just like, I couldn't believe there was no serotiny out there. So it's, we know what we're looking for. It's definitely mixed.
Great.